I finally found the time to start working on this, and this is my Commodore 64 Replica mainboard, and this is a replica of the 250466 board. And this board is reverse engineered by Rob Peepo Taylor, that's also done some of the other boards. And this is not 100% exact replica, but it's as good as, and it has the name, the 1986 60 clone stapled on it. This board I plan to populate it with almost entirely parts that has never been in a Commodore 64 before. And the only chip that I don't have as of now that is not either new on shelf or is a modern replacement is for the VIC-2 chip. Everything else I got covered. So I will start with putting in some sockets and stuff here, and I'm going to use some zero insertion sockets, and some of these sockets here, or some of these ICs, have a very narrow space around it, and that means that I might have to put some of these capacitors and resistors that's close by these sockets. I might have to mount them on the bottom side, and some of the parts I just picked from my parts bin, and some of these parts I've ordered especially for this build, and that is something like the power drossel L4, that's a noise suppression drossel that stands on the input, and the fuse holder here I ordered for this. Many of the other parts I do have in my parts bin from before. Most of them, I think. I also ordered some of the capacitors because these axial capacitors like this, they are not very common anymore. Sorry about the low intensity of the light, but I got a fault on my overhead lamp here. I'm just going to show you some of the problems we will have with fitting SIF sockets on this board. And if we take here the SID as an example, this is a 28-pin socket, and if I try to place it like so, you can see that it covers these resistors here. You can also see that it will cover this one over here, and also this arm here will go down like so. And these sockets can be mounted either way. You just have to mark what's the right orientation on this, but either way, whichever way you turn it, you will cover at least these three components. And on the SID, these are three capacitors, and we have the same with the CPU socket. It will cover at least this capacitor here, that's the decoupling capacitor for this chip. And that's possible. You can just bend them outwards so that these sockets will fit anyway, but you will get some conflicts if I will try to put both the socket on the SID and on the PLA. You will see that this lever here in some cases will inflict with the other components. So this is something we have to take into account for each of these that we want to replace with the SIF sockets. If you are looking over here, you will see that it's not possible to put SIF sockets in all the ROM sockets because they are too close together and these sockets are too wide. I can have the character room and the kernel room can be like so, but then the last one won't fit inside here. So it's not possible to replace every socket on a C64 with SIF sockets, and every one of these has at least a conflict with one component. Most of them have conflict just with the decoupling caps, and those I can mount flush to the board, or I can mount them on the underside of the board. But this is some of the problems that we are facing with the SIF sockets. And here I have lined up, just thinking of showing you this tip. This is how I normally do when I pick resistors for the parts list or booms like this. I just push the resistors through the paper, so I will have them sorted here in the list. One of the parts we also need to get done to make a replacement Commodore 64 board without sacrificing new boards is the RF modulator. And I do think actually I have a RF modulator that's new on shelf from back in the day, but as of now I really couldn't find it. So I'm making this RF modulator replacement, and this is a design that's been floating around on the net for some time. And I do think that this actually PCB is made by Barses. It's spelled BARSZ. And I've never tried this particular design before, and I do have all the components lying around that you need to complete this, except for the 10 microhenry inductor that should be here for L2. But I have ordered that, so this will be ready when that time comes. So I'm now just going to solder in these parts for this. I can mention that I didn't have a 330 picofarad capacitor, so this is a 220 and one that's about 103 or something that's put in parallel. And as this modulator is a universal design that's designed to work both on the long boards and the short boards, there are some jumpers here to set which direction the 5 volts should flow and so on. And we're just going to make these jumpers by bending these wires and solder them down, as this will be placed in a long board version of the C64. Yes, then everything is finished except for that we are missing the L2. That should be the 10 microhenry inductor. But that can be soldered in afterwards. So on the C64 board, this will go like so. And we have some adjustment here in height-wise. But since this is not going to connect to the back, it's just to fit it like so, I think. And by the way, this is the exact same modulator replacement that Arctic Retro featured in their December 6th episode of their Christmas calendar. You can check out his video on this topic too. As I'm going to populate as much of this as I can with the SIF sockets, I do have to make some sacrifice on the components beside here. But to map out where I actually need to put the sockets and where I need to reroute some components, I'm actually going to take this pen and I'm going to just draw a thin line around the sockets. That way I will see which components affect them without placing the sockets, because these sockets is quite big, so it's kind of nice to maybe fit them last. And there are a lot of capacitors and some resistors that I need to have a plan B for how I should mount them, because these sockets are so much wider than the ones that was used originally. I can wash this away with isopropanol afterwards if I don't want the lines to be here. Yes, like so. Now I think everything is marked good enough. So now I can take out these sockets and see where the outlines will be. Yeah, I don't know if you will be able to see the outlines here, but you have around here, you can see that these legs on these resistors will affect this somewhat, and this capacitor is fully hidden underneath the socket. So this one I will need to just solder it in and bend it outwards like so. And that will be the solution I will choose for most of these. Maybe on this case around the SID chip, I need to place C93 on the bottom because C48 and C93 will be on top of each other, and the same with C10 and C50. So maybe around the SID chip I just fasten every capacitor on the bottom. And here you have the R1 resistor. If I just push it a bit to the side, I will be able to put this SIF socket in. And around here you can see that C53, C15 and C101 will be affected, but these I can bend slightly. So that's what I will be starting with. I think I will just now start with the components, and every component that's inside one of these lines I have to find a solution to that when I come as far as to handle that. The first thing I will start on this board is the resistors. I have all my resistors lined up like so. I normally do it like this when I have resistors. When I pick them, I just punch them through the paper so I can see what should be where. I don't have to measure them or read the colors when I'm soldering and placing the components. So that's what I will be starting with just now. The holes on this board is rather large, so all the small components as capacitors and other stuff, they have leg room in these holes. The legs on the resistors was rather thicker back in the days. Here I actually have a fault in my picking of resistors. I'm missing R50 here. That should be 1 mega ohm. I will fix that afterwards. And this is 100 nanofarad decoupling caps. I'm not sure if I have enough in here or it is too many. It's just a common bag with this. And for some of these I have to be careful as they are inside underneath the sockets, like this one up here. So I'm actually going to solder this like so. It will be bent so that it sticks into the circuit board like so. So that I have to be careful when I start the soldering. And I have the same down here. Because this one I can actually solder them from the top here, because this board is through plated. Yeah, that was also hard to reach. 100 nanos, I do still have some up here that's other values, but I have to take them afterwards. So for now I just stick in the rest of the 100 nano capacitor. Yeah, and here you can see what we have done. You can see the yellow outline here is marking 3 capacitors that we have moved, and the stippled line here is the outline of the socket. So what we have done is that we have extended the legs on the capacitors and we have bent them so they're flush with the board, and we have just soldered them in so they don't take up space underneath the socket. That way we will be able to put the socket almost straight to the board, and here down with the SIF socket, this capacitor is placed on the bottom and this is just bent to the side. So that's the way we solder this around the board. Just give them a quick tug on this from this side so that they will keep still when I turn the board. Yeah, now it's just to turn the board over to see if anything falls out, and we just continue to solder in the legs on the other side. I prefer this method with just tugging them on one side before I turn the board on large projects, because it's much easier to do it one piece of a time. Otherwise, I just prefer to stick in all the components and then turn the board, but on this rather large board, that's not the practical way to do it. Now it's time to take the rest of the capacitors, and I've taken most of them and fastened them in the same way as the resistors on the boom list, so I just pick them and place them on the board. And some of these is also components that go beneath the sockets, so that I have to be careful to bend them away or mount them on the other side of the PCB, as we do with one of the capacitors here. The others, we just bend them so they will be sticking out from the side of the sockets when we solder in the SIF sockets. Cut the remainder of the legs underneath the PCB, it's important that you don't cut them too close to the PCB. It's also a good opportunity to see that every part actually is soldered down. And now it's time for the sockets, and it's not the SIF sockets. This time we first take the ordinary sockets, and every chip on this board will be socketed for making it easier to swap chips. My method is that I place the socket and then I take and bend 2 or 4 of the legs of the socket to keep them in the hole. And then when I've soldered 2 or 4 legs, I just turn the board over and I heat the joints and I just push the socket down to the surface. My experience is that this is not a slower way of doing it than tacking it down with something from the other side. Now it's time for the bigger electrolytes and the resistor arrays. And the resistor arrays, we do the same as the other. We tuck them down with a solder in the middle from the top. The small transistors in the TO92 caps is easy to place because the direction of the transistors is marked on the PCB. This TO220 transistor is for driving the cassette motor. Even though it's a space for it, I never seen it fastened with a screw and used the earth plane as cooling. This soldering iron, even though it should be 80 watts, it cooled down so fast that it's not good for soldering the components to the ground plane on this board. And then it's time for the SIF sockets, and those I take one by one and make sure that they will fit beside the components that we have bent out of their way, and that we also get them firmly attached to the board. So I will solder them just 2, 3, 4 legs and push them straight to the PCB, and we do the rest of the soldering in the end. The crystal is not the same kind that's in the original version. This has a much shorter package. But even though I think it's important to solder down the ground cap to the marked points here, so I will bend it and place a wire over this to keep it firmly attached to ground. The joystick ports I got hold of here is the original kind. If you try to buy some modern replacement, they will be much shorter, and the holes and they won't go as far out as the edge of the board. But this one is got from Digikey, and they is an exact match. This is an original Commodore new on shelf power switch, and this was a replacement that I got from Commodore back in the day, and I actually have maybe 3 of those left now. And the same is true with the cartridge connector. I actually dug up 2 of those from my old spare parts. I had to break out my trusty Wheeler soldering station, as I couldn't get the soldering against the ground plane good enough with this R&D crap. And by now I found my big bag with 1N3148 diodes that I couldn't find, so now I'm going to put in the rest of the diodes. And now it's time for the DIN sockets, and luckily all the DIN sockets only fit in one place, and it's for the serial, the audio video and the power connector. And these are all parts that I've ordered from China some years ago, and they are pretty good quality. And then the only big part left is the RF modulator replacement part that we soldered earlier, and we are just going to put the 10 microhenry inductor in place, and we are going to just solder it onto the board. The height of this doesn't matter as there is no connection in the back on this, but we do like to keep it so that it won't short circuit against the board, so I try to keep it level. Yeah, then it's just a quick manual inspections of the parts from the top before I start soldering everything, and yeah, make sure that every solder joint is okay and is actually soldered. And here I really benefit from my over 30-year-old Weller soldering station, because this is much quicker than anything else I have tried when it comes to soldering diversified sizes of pads and components. This is Koiro with just a short comment about the video you hopefully just have watched or fast forwarded through, or at least I hope you have, and that you're with me to the end. And the comment is about what's the reason I did this build. Because this is not so much about just making a replica C64. Others have done that, and this has been featured on YouTube before, and among others, my friend Tommy and Arctic Retro has done a similar board, and the same with Jan Beta from Germany. They have also built C64 boards like this. But my purpose of this board is that I wanted to build a board from scratch that I can use to fault find some old components without sacrificing a new C64 board. And I do have some boards that I don't have the computer to, but anyway, I didn't want to destroy or break any old Commodore machine just to finish this project. And the reason that I did this now, this has been long in the making. It's in over a year since I started planning to do this, but several reasons has made me postpone this. Among others, it's the work situation, and it's also the conditions I need to do Commodore 64 repairs. I need access for periods to oscilloscopes, I need for multimeters, and I need for the soldering station and everything to be ready to go. And I also need access to some PAL and NTSC monitors to hook this up to actually do the tests and checks. And also I don't have had access to all the equipment I needed yeah, in a place where I actually can work on this for a long time. My main equipment is what's placed in this room and on the shelves here. And this is a room I share with two other members of the family, my two boys. So I don't have the opportunity to work continuously from this room and also doing videos about it. So what I have done now is that I have actually placed some oscilloscopes and some more equipment down in my shed and also down in the bunker so that I can actually do some filming without needing to occupy this room. And that's also the main reason why this has taken some time. But hopefully in the next couple of weeks I will start slowly with bringing out some of my old Commodore 64s and do some fault finding. Maybe I do some repairs. But I have a lot of Commodore 64s and my dream is to at least fix as many of those as I can. And I also have some peripherals like printers, disk drives, tape recorders, joysticks, and cartridges and other stuff that we also need to test and we need to maybe do some maintenance work on. And that's the main reason why I did this video. And in the next part of this video I will be populating the board with components and new on-shelf components for everything except the wick. And I also will be placing this in a new replacement cabinet. And I will be using one of my old factory replacement keyboards. But that is a slight lie, because I only have two keyboards that I failed to return to Commodore. Because when I got a new keyboard from Commodore, I had to send in the old one almost straight away. But sometimes I needed keyboards to do fault finding and other stuff, so I often kept one or two laying around that I didn't return. And I actually have two of them that I did not return back in the day. And that is one C64 keyboard and it's one original keyboard from the bread bin. So those one of those I will be using in this build. So hope you enjoyed the content. Thanks for watching. At least I hope someone is watching. And please hit like and subscribe if you want to follow what we do on this channel and if you like the contents. So, thanks for watching. Hope to see you in the next episode in a week or so.